Okay, we've got a question about a histogram. So this is about throwing the cricket ball competition. This is the distance they throw it, and this is frequency density, which is what we always have on histogram. Frequency density up the side. Okay. All right. So what we need to remember here, and what it tells you at the top of the page, is that it is area of the bar that tells you the frequency. So the frequency density is calculated from that, but we're going to be interested in the area of the bar because that is telling us the frequency. Okay, and we use histograms for grouped continuous data. So when we get onto part A of this question, why is a histogram a suitable diagram? It's because this is a distance is a continuous scale. You could measure it to any number of decimal places if you had the accurate enough equipment. So answer to part A is simply because histograms are suitable for grouped continuous data. And we get that into context. We mentioned that in this case we've got distance thrown, which is continuous. How many people entered the competition? So, okay, what tells me how many people is not the height of each bar. This is not 2 people. This is 2, but its area, it's got a height of 2 and a width of 20. So the area, the number of people for the first bar, the frequency is the area, which is 2 times 20 for the first bar. Okay, and then for the second bar, this is a width of 15, and the height of it is looking like 5 times 15, and we carry that calculation on. So you should really do the rest of that calculation yourself. Pause the video. Have you done it? Have you done it? Okay, so that's how the other terms come out, and this is what it all works out to if you do it properly. Okay, so you get 310 people. Hope you got that. Good. Now we've got to estimate how many people threw between 30 and 40 meters. Okay, now it's an estimate because this group here, the one I got wrong, was 75 people. I don't really know how those 75 people are distributed between 20 and 35 meters. Okay, the histogram makes it look like they're all evenly spread out, and that's the assumption I'm going with. So what I'm going to do is I'm going to assume that for 30 and 40 meters, I'm going to assume that I've got this area here, okay, and this area here. So I draw the lines up at 30 and 40. So that means I've got, this is 5 and this is 5. So I'm going to have 5 times 5 plus 5 times 10. So in part C, the calculation I do is 5 times 5 plus 5 times 10, which is going to be 75. 25 plus 50 is 75 people. Okay, and similarly for this one, how many people threw between 45 and 60 meters? Okay, well, again, it's an estimate. Okay, so it's going to be 5 times 10 again, and then it's going to be all of these people. So all of these people is my 6 times 15. Okay, oh, so sorry, between 45 and 65 meters, misread it. So in fact it is, it's not an estimate, it's this bar here. I know it exactly, it's this 6 times 15, which is 90 people. So D is 6 times 15, which is 90 people. And then E, I've got to estimate how many people threw less than 25 meters. So that's 5 in this bar here. 5 times 5 is 25. So 5 times 5 for that one. And then this one is 20 wide, and 2 plus 20 times 2, or 2 times 20. So that's 25 plus 40, which is 65 people is my estimate. Aren't histograms easy? Oh, except we need to be careful. 45 and 65 this one was. So I've just gone from 40 up to 60. So there are these little people here. These 1 plus 1 plus times 5 is actually 95 people is my final answer, because I forgot to get up to 65 before. But I've got it right now, and I still think the histograms are pretty easy.